Welcome back to our YouTube channel. Today we are starting a new topic in our Verilog series, that is data types. Before we dive into the topic, I would like to have a brief recap about whatever we learned in the last video. We take a look at the basic structure of a Verilog module. As we discussed, the overall Verilog design is made up of individual building blocks named as module. In module, there are ports which define which can be defined as input or output ports from where the design can take input and provide output. Then there can be some internal variables which can be used to perform some internal logic, and based on that logic, the output is generated. So this is the overall module syntax or structure. Now here, if you take a look at the variable A and B, they have been declared as data type reg and wire. So what are these reg and wire data types? And how are they different from data types which are found in any programming language? So first of all, Verilog is not a general purpose programming language like C or Python, as we have mentioned many times earlier. In Verilog, the main requirement is that we need to define some hardware, as that is that is for what Verilog is used. Verilog describes actual circuits, not just like int, float, or string. They don't have any meaning for a hardware, as you can't have a hardware which is directly storing a string. Hardware can ultimately just store 1 or 0. So, what we need are data types which can be actually mapped to some hardware. And whenever we think about any electrical circuit, the first and the most basic component which comes into our mind is a wire. Without wire, I don't think so any hardware circuit can be made. So for that, Verilog provides a data type which mimics wire, and even the name of the data type is wire. As we took a look at, we are looking here that the variable b is declared as wire. So b will act as a wire. Now, what are the properties of wire and how does it actually work? We will be taking a look at it in this video itself. Now, we have talked about wire, but as we know, wires only contain electricity or data while they are connected. Once we turn off the supply, wires don't hold any electricity, or we can say, in other words, that it won't hold any data. So there's no memory for wire. But we know that there are many situations for which we need to store some data. So how can we do that? To mimic that kind of wire, that kind of elements, Verilog provides us a support with a data type named as reg. Reg are data type which are used for mimicking any storage element, and they are also used to mimic any flip-flop latches, any sequential element. So wires are ultimately used for connection, while registers are used for storage and sequential logic. Now, let's dive deep into what are wire and what are registers. We can classify all the data types in Verilog in broadly two categories. First is net type and second is reg type. As we discussed earlier, wire is a type of a net type data type, net type category, which represents physical connection, and they are automatically updated whenever the logic changes. That is, if I if a wire is connected to a power source, whenever power source is on, the wire will conduct electricity, and the power source is off, then wire won't conduct any electricity. Hence, on the other side, we have reg type. Reg type are the data types which can be used to store some values. These are used in procedural blocks. Now, what are procedural blocks? We will be taking a look at it in the further videos. For now, you can say reg type data, any reg type category data type is used to store data. And reg itself is a data type which comes under reg type category. They will hold values until they are explicitly changed. Once we have put some value in a reg type data type, it will store that data unless it has been overwritten. Doesn't matter if the connection has been cut short. Then also it will keep storing on the data. Now, What are the possible values the data type can take in Verilog? In any programming language, any data type can take either two values, 0 or 1. That is the integral data. They are known as integral data type. But in Verilog, there are two more logic values which any variable can take. So let's take a look at all the four possible values which are available and the what are two extra values that Verilog provides. The first is value 0. That means logic low. It's simple. Whenever we are connecting any circuit to ground, it provides logic 0. Then we have value 1. Whenever any circuit has been connected to VCC, it provides logic high. Now, what is X? X is used to represent condition when the value is undefined. This can a value of a range type or any data type can be undefined if it hasn't been initialized. That is, if there is a register which hasn't been given any values, then it will have default value X. Let me go back to the first example which you saw. Here, I have declared the variable reg A. Now, unless until I provide some specific value to variable A, which is of reg type, the value stored in variable A would be X. That is, by default, it is undefined. So X means unknown or don't know state. This is used to show that the value has not been defined or there are some conflicts occurring. How can a conflict occur? What are conditions? What are multi-driver condition which leads to X? We will be taking a look at it into with practical examples as we go in and learn some more concepts. What is Z? Z means high impedance. In practical scenario, if I have a wire, then wire is not connected to anything. It's not connected to ground or it's not connected to a voltage source. Then that condition is known as high impedance, that a node is floating. So no driver is actively driving a signal like a disconnected wire. That is known as high impedance. To mimic such scenarios, Verilog provides the value as Z. The default value of a reg is X, but the default value of a wire is Z. It should be obvious as we discussed earlier. Wire, when it has been not been connected to anything, it should be high impedance, as we know from practical scenarios. While reg is used to store some data. So if reg has not been initialized some value, it will be X. Now let's take a deep look into what are the variable net type available for us to be used in variable. Net types are used to model wires or connection in real hardware as we discussed earlier. They do not store values. Value is determined by what's driving them. If the driver is providing logic 1, then wire will have logic 1. If the driver is providing logic 0, it will have logic 0. And if no one is driving the wire, the value of wire will be Z. Now wires cannot be assigned inside always or initial block. Must be assigned using continuous assignment. These are the methods by which we can provide values to wire. In the further videos, we will take a deep look into what are always or initial block or what are continuous assignment. For now, you can understand it as to provide values to wire, we use assign statement. This is a keyword which continuously drives a value to a wire, like a physically connected voltage source. Then the value wires automatically updated when drivers change. And they don't hold any previous value, they reflect the most recently driven logic. So what are wires ideal for? They're ideal for connecting any net type data, not just wires. They're ideal for connecting gates, assigning outputs, or modeling buses or signal lines. Mainly interconnects between complex logic. That's what wires are ideal for. These are some of the wire or net type data type that are available in Verilog. First is wire, as we have detailed discussion on it. The next is tri, which is tri-state wire. This can support multi-driver situation. It can also have floating Z support. The common use of tri-state wire is in shared bus or I/O protocol. If there are a wire which is having multiple driver situation, for that tri-state wire is a good choice. Then wired end. This is used when there are multiple wires connecting to multiple inputs connecting to a singular wire, and we have to take end of the complete signal values. For this wire end can be used similar wired OR. We have multiple drivers and we have to take a OR result of all the values. Then for that wired OR can be used. Now let's take a look at a simple module for NAND gate. How we can use wire and simple assign statement to model a NAND gate in Verilog. First of all, as we mentioned earlier, we declare module using module keyword. Then we provide a name. The name I provide is NAND gate. Then I need to declare input and output ports. As I mentioned earlier, you can declare the input port variables here and provide the direction inside the module, or you can directly provide the direction here in the argument itself. Input A, B, and output is Y. Now we declare a wire temp. Then we assign temp is equal to A and B. That is, we end both the input pins A and B. Then we assign Y is equal to not of temp, where here we do the AND operation, then we do the NOT operation. Hence, it becomes a NAND gate. This was a simple module for NAND gate, which uses wire, assign keyword, and operators like AND and NOT. We will be taking a deep look into what are all other operators used in Verilog and what is the assign keyword in detail. For now, I hope the example is clear. Now, reg data type. Reg stands for register, but doesn't always mean a hardware register. It simply means a signal that can store a value. As we discussed earlier, the reg type category are the data types which can store some values. For that, the value can be regained over a time. That's why we need reg type data. And to drive reg type data, we need to use always or initial construct. Then they can be updated based on events like clock edge. Hence, they are perfect for modeling a sequential logic like flip-flop, FSMs, etc. Here are some of the reg type category data types available in Verilog. First is reg, which we had deep discussion on it. Then there's integer. Now you might be thinking, I mentioned that we don't use integer, real, or string, any type of data for harvest. It's true, but Verilog is not Verilog. Other than using it for HDL, we also use it for verification. Whatever design that has been made, if we want to verify the design, for that we can use integer, real time, or real time in test bench, because these variables, integer, real time, or they are not at all synthesizable. What does synthesizable mean? Synthesizable means any logic which we write should can be converted to a hardware, then it's a synthesizable logic. The logic which we write, if it can't be converted to or mapped to real hardware, then it's a non-synthesizable logic. So focus what we so whenever we are designing a module, if we want to make it to hardware level, then we must focus on only using synthesizable logic. And for that, we use reg type. It's synthesizable. Now let's take a look at the example. We have module counter. Now we have some input clock, reset, and output reg. Here we explicitly declare output as reg. Why? Because we want the reg count. It's a counter. So until the next passage of clock comes, how does the counter behave? At every edge of the clock, counter will increment its count. We are sure about that. So if the value is not stored in the count till the next increment comes, then we won't be having proper behavior of a counter. And wherever we don't explicitly declare the data type in the input or output pins, then by default it's declared as wire. Now we are having a always block. Let's not go into detail that how does it always block work or what is that. Just focus on this simple logic that if reset comes, the counter value should be 0 and else counter should be incremented to 1 at every process of the clock. That's all this means. And for such scenarios, the reg data type is perfect. I hope this provides a good introduction and clears any questions you might be having about Verilog data types, why we need a different kind of data type in Verilog, both net and register type data, and what are all the various type of data type available in Verilog. After this, I would request you to go through all the other data types which are available in reg and net type. You will find them at many websites that explain them in detail. I am not going into detail because right now is for some people this might be they might be new to programming concept as well. Hence, I am focusing on all the primary data types which will be required for hardware modeling. Those of you who already have some basic idea can go and explore. And if you are having any doubts, you can always reach out to us or you can ask in comments. We will be happy to help you. Also, I have just one assignment for you after this video. I want you all to watch the video completely and provide me three key differences which you noticed between a reg and wire. Three key difference between reg and wire. And please make sure to comment. Thank you.